Hi there, I'm Bono. Today I want to show you what I've made with KiCad. First, a quick word about who I am. I go by Bono, and I work as an engineer. These days, I post about technology and electronics on YouTube and on my blog. The tools I live in are listed here: KiCad, Fritzing, LT Spice, MATLAB Home. For context, I've entered a hardware contest called Zuken a few times. There's Mimi, which watches over a child by sound, and the cocktail cube, an ice-shaped gadget that fills a room with the color of your drink. I built both with the tools listed here. As for what this video is about, I want to focus on KiCad. It's a must-have for anyone into electronics, but there's very little documentation, and hardly anyone shows what they've actually made with it. So I decided to share mine to show what it can do. Before the examples, let me cover the basics of what KiCad is. So what is KiCad? Put simply, it's an all-round schematic and PCB design tool. I've listed 3 things here, and the biggest is that it takes you end-to-end in one place. KiCad handles everything from drawing the schematic to laying out the copper to exporting the Gerber data. You really can go from a circuit on paper to a finished board without leaving it. It also fits any scale, from a simple single-sided board right up to 10 layers or more. I believe it goes up to 32 layers. Not that many people will ever need that. And there's automatic design rule checking and auto routing to pull the traces for you, so it really does cover everything from hobby work to professional use. And then there's the fact that it's free. Honestly, getting this much capability for nothing is remarkable. Commercially, the nearest equivalents are Zuken's CR5000 and CR8000, and those are strictly professional tools that run into millions of yen. KiCad is free for anyone, and that counts for a lot. My own hunch is that, of all the schematic and PCB tools out there, KiCad will end up taking something like half the market. The other thing I wanted to show you is this, and it's the main reason I recommend KiCad, the 3D viewer as it says here. As you can see from these photos, KiCad lets you check the board in 3D, so you can see how it will look before you commit. That is enormously useful. Say 2 parts sit too close and won't fit, a mistake everyone makes at some point. In KiCad, you see it with the parts already placed, so you catch far fewer. And beyond that, seeing it in 3D is simply good fun. If you want board design to be enjoyable, this is the one to try. Right, that's the quick tour of KiCad. Now let me show you what I've actually built with it. I've picked out 4. The first is a test jig board for electronics work. As the photo shows, it's a simple thing. What is it? It's a straightforward test jig. There's a connector for a USB cable and a connector for a headphone jack. On the back, there's a DC-DC converter to step the voltage up, so it can boost a little and drive a fan as well. I'll come back to this one later on the KiCad screen in more detail. Next, I made the board for the cocktail cube in KiCad too. It's a little hard to make out, but it's split into 2 boards. The left one carries the color sensor. There's an IC for the sensor in the center, with a few resistors around it. That's all it is. The right one holds the coin cell and a connector for the cable. At this sort of scale, a board costs about $1, so there's no reason to hold back. Next, I built an FV converter. The circuit itself comes straight out of the part manufacturer's datasheet. There's a connector, the FV conversion IC, and a few supporting parts on the front and the back. And to mark the board as mine, I put my name and the date on it. The fourth and last one is this, a pulse transformer board for a gate driver. It's the circuit you use to drive a FET while keeping it isolated. And I didn't have a good board to hand, so I decided to just make one, schematic, copper layout and all, and had the board produced. This one carries the date and my name as well. So those are the 4 things I've made with KiCad. Now for the first one, the test jig board, let me show you how it was made in KiCad. So this is the schematic screen in KiCad. This is Eeschema, the schematic editor. As I said earlier, the circuit itself is simple. There's the USB connector, there's the headphone jack connector. Each pin is wired out, so you can pick off the signals. The pins on this USB connector are brought out too, and it steps 5 volts up so it can drive a fan as well. So the voltages can be tapped anywhere. I put a few extra pins on. Once the schematic is drawn, you assign a real part to each symbol. That's this screen. The parts are listed here, numbered 1 to 33, 33 parts in all. You choose which part goes with which symbol and assign them one by one. Once every part is assigned, you move to the screen called Pcbnew and do the actual board layout. Here I'm making a 50 by 41 millimeter double-sided board. Several layers overlap, so it's busy, but the green area is the copper pour. You can see some thin lines running through it, and those are the signal traces. You can put whatever you like in the silk screen, so mark it up however makes sense to you. From this screen, if you click 3D Viewer under the View menu, the board comes up in 3D like this. You can assign a 3D model to each part as well, and once those are assigned, when you open the 3D Viewer, the parts show up in 3D too. This was only a simple jig board, so I didn't go that far, but do try it if you're curious. I'd like to cover how to do that in another video. So that was the tour of my little test jig board. One last bonus. Once you're comfortable, try having a board actually made. Isn't getting a board made hard work? Doesn't it cost a fortune? A lot of people worry about that, but it really isn't like that at all. I've listed 4 points. A board can cost as little as $1. This was true for me as well. When I first heard it, it floored me. Every board in this video was made for about $1 each. There are plenty of board houses out there, and the usual choice is a Chinese one called Elecrow. The Elecrow site looks like this, and if you go there and click PCB, you land on the order page where you spec the board. You pick the number of layers, you pick the color of the board, it's all up to you. As it shows here, under PCB quantity, 5 boards come to $4.90, which really is about $1 each. There's some shipping on top, but even so, I think you can see how cheap it is. I'd like to walk through these settings in another video. As for lead time, it depends on how you ship and what you pay, but a week is typical and a month at the outside. The one thing to know is that it's all handled in English, so it may feel daunting at first. If you get stuck, leave a comment or send me a DM on Twitter. I'm happy to help, so do get in touch. Right, to wrap up, KiCad is a must for electronics work, and if you use it, do play with that 3D viewer, and once you're comfortable, try having a board made. Those are the things I wanted to get across. And that's it for this video. On this channel, I post about technology and electronics. If that sounds like your thing, please do subscribe. And if there's a video you'd like me to make, or something here that wasn't clear, please leave it in the comments. That's all for today. Thanks for watching.